thing that we are going to develop for today is all of the basic parent graphs of every single log graph. And we're going to do our transformations in the next couple of days with them, but you are going to be asked to graph log base 4 of x. Right now, we are going to do it in 2 steps. Eventually, all log graphs I'm going to ask you to graph directly in 1 step. The 2 steps that we're going to do right now, though, is we are going to first graph the exponential graph 4 to the x. What does that look like? Well, we've graphed lots of exponential graphs already. I hope you know that all exponential graphs have a point 0, 1. And all exponential graphs, when you plug in 1 for x is really easy to do mental math-wise. You get 1, 4. And our exponential graphs either increase or decrease. This one, based on those points, increase, and you have an asymptote at y equals 0. Now I can graph y equals log base 4 of x using the idea of inverses. So if 0, 1 is on the point of 4 to the x, does it make sense that you would have 1, 0 on the inverse? And if you have the point 1, 4 on 4 to the x, then you're going to have 4, 1 on the inverse. And if you have an asymptote at y equals 0, and inverses switch x and y, so instead of y equals 0, you will have an asymptote at x equals 0. With that asymptote and those 2 points, you can draw the graph. So for this very first one, we used the inverse graph to graph the logarithm. But the expectation moving forward will be, if I give you a log graph, you should be able to graph it directly. So we'll do a couple more just to practice. But before we do that, we're going to identify the intercepts. So this one has an x-intercept at 1, 0, but no y-intercepts. The equation of the asymptote is at x equals 0. The domain, x is bigger than 0, and the range, y is everything. But we're going to do a couple more. Let's say I asked you to graph y equals log base 2 of x. I'm going to expect you to graph it directly. I'm going to expect you to know that all log graphs, all basic parent log graphs, have an asymptote at x equals 0. I'm going to expect you to know that all log graphs, just like all exponential graphs go through 0, 1, all log graphs are going to go through 1, 0. And if I plug in 2, two to what exponent is 2? 2 to the 1 is 2. So you will have the point 2, 1. Just like in the first one, with the base of 4, you had 4, 1. Now you would have 2, 1. And there's our log graph. If I change it to log base 5, everything would be the same, but you'd have the point 5, 1. If I change it to log base 382 of x, everything would be the same, but you'd have 382, 1. And if I got you to graph y y equals log base e. Remember we learned the new number e, which was 2.718? If you had that new number e, you would have an asymptote here. You would have the point 1, 0, and you would have the point e, 1. And so special is the number e that they gave this graph its own logarithm notation. So every other base uses log. 10 is special, you don't have to write it if you don't want to. And e is even specialer, I don't know if that's a word, even specialer, in that you can write ln instead of log. ln, it's like French, logarithm naturel. So they log natural. It's called the natural log. And it's ln because it's like log natural. What do you call it in German? How do you say natural? How do you say, like logarithm is going to be very similar. So how do you say natural in German? Okay. All right. So questions for graphing are 10 and 11. Test is tomorrow.